Alright, I'm going to design a new circuit board. This circuit board is an adapter to go from a GatesAir FAX Series transmitter, like a 3.5, a 5, a 10, 20, 30, 35, 40, whatever you got, to a Burk ARC Solo remote control. Right now there's no real way to do it except to do a bunch of wiring, and I think what I'm going to do is set it up so you get a bunch of RJ45s. You get a DB25 on the transmitter. You go from the DB25 on the transmitter to a little adapter board that hangs off of a cable. You bolt it up where the hell you want to. And then from that, you go from a bunch of RJ45s to RJ45 to 6-pin or 3-pin, whatever you got, Phoenix adapters that go into the Burk. And that should make it a lot easier once you get it done. And now, of course, I just found out I didn't record any of that. Well, if you're just joining us, here's a schematic I captured into Express Schematic that I'm going to export to, or import into Express PCB onto the schematic I'm drawing over there. Oh, how am I going to do this? Let's add a 4-position Phoenix strip that just connects to those user things. User outputs or inputs or whatever. Well, I wonder what I should do with that. That's kind of a waste of connector. It's a status input. Alright, we'll just take the rest of these off. Alright, we'll do this. Make P9. That'll just be a header. And you can just plug whatever you want to into that header. Okay. I don't know how ugly this is going to be because the resolution's a little bit low. It's kind of translating, but we'll see. I'll show you. Alright, acceptable, I guess. Add some audio to her. Add existing microphone aux. And now, if I flip this, click the transition button, that should give you Express PCB. Neat. Alright, so let's make a new one. We need a DB25. And it needs to be, okay, the transmitter side is DB25 female, so this one needs to be DB25 male. DB25 male, right angle, ding, there you go. There we go. All right. Right there is good. Now RJ45s, comma 8. There she goes. 4, 5, 6, 7, 8. Loop that half the other direction. I always like to leave a little bit of space just in case things go wrong. Sometimes there's parts availability problems and you got to order something else, make it fit. Oh, wait a minute. I know. Hold on. I forgot. Let me run another instance of this program. Under boards, we have a DBRJ, we called it, which is, it should be the latest one is the universal, revision B, DB37RJ45. There it is. We'll just steal the plug off of that. Well, sorta. That's not. Alright, this'll work. File new. You can't see what I'm doing, but I'm doing some cool stuff. Just making a DB25 or an RJ45 with the solder tabs. I copied it off another board that I built. RJ45 with tabs. Alright, so now go to save. FAX Series RJ45. Open. Whoops. Not you. Alright, see we've got an extra hole on each side for tabs, for the solder tabs, if we use solder tape, or if we use metal connectors. If we use plastic connectors, it doesn't matter. Okay, now just paste that back in, and there you go. The neat thing is, I think I designed this so that if you put these side by side, each connector's tabs will fall in the holes beside it. So if we do this, make another one. If we line these holes up exactly, then the tabs should fall into each other's holes. Now all we got to do is copy this. Well, I think if we delete one of each of these, nope. There we go. Rotate. Stick her back down. Oops. Poop. Alright, that should do it. So then we'd move the edge of the board to match that. On each side. There we go. Alright, nice compact little board. I'll move these back a hair. Oh, we got to make mounting holes, don't we? Oh, we can just make them straight down the center. Well, nah, you want to have a kind of a squarey type of deal. Alright, let's bring this out of here. Let's see, 1, 2, 6. Alright, we'll do 1, 2, 3, 4, 5, 6. That'll do. Alright, now we just put some holes in it. And you can put your customer provided standoffs and mounting brackets and whatever else you want. What size do we need this to be? Hold on, let me Google this real quick. Be like a number 6 machine screw. Size of screw, 0.138. Close fit, 0.144. So if we go 0.15, that should give us plenty of room. Let's give her a 0.167. Alright, we're going to put that right there. Okay, 1, 2, 3, 4, 2.5 in. We're going to take this back a notch here. There we go. Gotcha. Oop. All right. 4 in and 2 over. 2.5 over. So we go 1, 2, 3, 4. 1, 2.5. There it is. Okay. Oh, I forgot the header. So P9 is going to be an 8-pin header. That's a 10-pin, so we're going to take 2 pins off it. Component, ungroup. Pin 10, pin 9, okay. If you look in the bottom left here, it tells you which pin you clicked on. So delete those 2. We don't really need that much room. Okay, we'll regroup it. There we go. We'll just put that on the end here. That'll work. That looks a little better. Well, there. Now it matches the rest of these. Well, that's easier to deal with. All right. P1. Oops. P2. Pay 3. Pay 4. Pay 5. Should we go in a circle? No, we'll go this way. Pay 6. Every single one of these labels has got to be in the wrong place too, doesn't it? Pay 7. Pay 8. I foresee that I think I might have screwed something up here. Hold on. 2, 3, 4, 5, 6, 7, 8, 9. Maybe not. We'll just delete that. I'll move this over here. I'll call that P9. Wait a minute, I botched it. There we go. Alright, P9. And then P10 is going to be the... Oh crap. I just deleted that header. Now I got to make a new one. Be alright. Alright, component, ungroup. We'll just delete, well, we'll leave this on here. Delete these two. Alright. Move this up that way. That should do it. Alright, we'll do a group. And we'll call that P10. There we go. That'll just be a header. You can plug whatever you want to or solder whatever you want to into it. Or we could put a Phoenix screw terminal on there. That would probably work too. We'll leave a header on it for right now. If you want to upgrade it, you can. Okay. Save it. Now we start. Here's what the fun part. Go to File. Go to Link Schematic to PCB. FAX Series RJ45 schematic. Now they're linked. No errors. That's good. So what you do is you click on this little pad continuity tool here. Whoops, where'd it go? Is this it? Yeah. No. Oh, there it is. Then it shows you every single pad that's supposed to be connected to. That one's ground. Oh, aha! Check it out. Found an error. P8. So we look at P8 on the schematic, and I got two grounds next to each other. Oh, that's okay. Yeah, that's right. Okay, we're good. That does look kind of weird, but orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. Yeah, that keeps the pair continuity. Okay, so what we do now, let's do a flood fill. Get a 25 thou off the end. .4, so 4.375. There we go. There we go. That's it. Okay, now we just copy that onto the next plane over. Copy it. Do that. That should, there we go. Cool. When you hit that, it forces it onto the bottom layer, which is green. The top layer is red, indicated on the software. There we go. Cool. So now we can see see, we've got a problem already. These pads were assigned as ground in another piece of hardware that I developed. So top layer pad shape, no filled. Bottom, no filled. You see what I'm doing is I'm severing the connections from these pads to the filled plane. Okay, I don't see any more filled plane connections that aren't supposed to be there. Now let us do the grounds first, since that's that one. Okay. Right click, top layer pad shape, thermal pad, bottom layer pad shape, thermal pad. Do that a million other times for all the rest of these. Why doesn't that have any grounds? Oh, whoops. We can fix that. Let me show you what I'm doing. Control C, Control V, copy pasta. And just call that P10. Save. Wait for the dingleberry to go away here. There we go. Okay, switch it back over here. Now we go to File, Refresh Link to Schematic, and there she is. That should, in theory, yep, there's the grounds. Cool. Alright, so now everything that's blue needs to be connected to the filled plane. Would probably have been easier to just do this at the beginning. Then we could just copy and paste them and they automatically retain their connection to the filled plane. Well, this will be alright. It's not that many. If it was a bunch more, we'd do that. We'd redo it, but this way is okay for now. I just make sure the thermal pad turns green before it turns red, so we have it on both layers. You normally want to use thermal pads because it makes it easier to solder. You know, it's got just a little bit of copper connecting it to it instead of a the whole complete blob. I may fast forward through this part. Oops. Nope, not solid. You don't want that because that will take too much heat to solder. I still don't like the looks of that. You got PA summary on pin 1, which is here. Normal ground on pin 2. Wait a minute, no, that's not right. P8. Equipment interlock on 1. Normal ground on 2. External interlock on 3. Ground on 4. Ground on 5. External interlock ground on 6. Huh. Well, I mean, that does go the way it's supposed to go. Orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. So green, green, white, and green. Green, white is external interlock, which is here. Green is external interlock ground, which is here. All right. And then the rest of them are just grounds just because. Yep, I'll deal with that. I dig that. All right. Do that. Two more, I think. Okay, there we go. Now these holes here, these tab holes for the solder tabs, they're already connected via thermal pads to the ground plane, so that works. I'll tell you what we're going to do. Let's put thermals on these too. Do the bottoms too. So now, all of those grounds are connected except for the external interlock ground, which is its own separate entity. Those are all connected to the filled planes on the top and the bottom of the board, We don't use component side or solder side anymore because both sides are component and solder and half the stuff I build nowadays. And the software calls it top and bottom, so that's what I do too. So you always want to pull your filled plane back from the edges a little bit too, just in case. Because if they cut it screwy, they leave a burr across, it'll connect the top to the bottom, and you can have all sorts of weird stuff going on. So I'd just rather not. Aha, I missed a thing. There we go. Okay, we're cool. All the grounds are hooked together. Now we start on the rest of the pins. Pin 1. We'll go up over here first. Just take the farthest route out, as far out as you can. Doesn't have to be a heavy trace, just has to be present, functional. We'll fan them out down here. Okay, 2. I've got to be careful around those holes, those mounting holes, because you never know who's going to put what sort of big old washer into there. Cause you all sorts of neat problems. Your board sucks. Yeah. That red and green is kind of harshing on my brain here. Ouch. I think that concussion did some problems. That's going to give me a migraine if I keep looking at it. I got to stop. Whoops. All right, there we go. We can move these up and around a little bit farther. We're not anywhere near close enough to the edge of the board to be a problem. All right, that should be getting away with the territory there. All right, number 3. Same deal. 1 notch up higher. and sideways. There we go. We can probably get those a little bit closer together. Yeah, it's pretty good. That'll do it. Doesn't have to be perfect, just has to be there. Has to be present. Alright, 4. Should be the 4th one in there. That's good, alright. Hopefully we can make it past that hole. These are a little bit crooked, but we'll fix them in post. I gotta be careful about that hole there. We might need to move that. I don't trust that thing. Alright, let's see what the 0.62, 0.531. 0.62, gotcha. Alright. 0.88. 0.81, let's make that 88. Oh, that's a lot farther apart than I thought it would be. Huh. Let's put them closer. There's not really going to be any crosstalk. It's all just analog voltage, low slew rate. There we go. There we are. Now, 62, 81, 100, 119. $62, 81, 100, 119. I'm just kind of straightening them up a little bit. It just looks a little better that way. These don't really matter. They can go however they want. Okay, next. It's nice that we only have to hook 4 of them up at each time. That goes there. That goes there. That goes there, and that goes there. So we can run those out, down, through, up. And the nice thing about this is when you click on the pad with the trace, it automatically highlights the other pads for you. Out, down, and to the right. There we go. There's them. We'll have to clean it up a little bit because I cannot let a board leave the shop like that. That is just harshing my mellow. I like to get the traces as close as we can without going over. That saves board space. It's just more efficient that way. And it looks better. More professional, I suppose you could say. To an extent. I kind of don't like to do the weird angles, but oh, there we go. That'll do her. Cool. Break the trace and split her off right there. I like everything to be nice 45s and 90s and stuff. Let's save before we have a power outage and lose everything. Alright, we're a fifth of the way there. Almost a quarter. Okay, next. We may have to go down to the other layer. And to verify your work, all you have to do is just click on each pad, verify that it's connected to the other pads that are lit up when that lights up with your continuity tool, which is this, and that's it. So I think what we're going to do is sneak it up around there, down. I don't like to go, You normally want to use trace biasing to go like one direction on the top and the other direction on the bottom. So like the top goes vertical and the bottom, all the traces go horizontal. As close to that as practicable, but in some cases you can't. Where does this go to? P7 and P9 are both connected. Why? Oh, because those are oh, whoops. P9 was supposed to be the header. Alright, I can nuke that and that. Take this. Do that. Do one of these. There we go. So now P7 and P10 are connected. We just do the same thing for both of them. Straight up. Oh, gotta update the schematic. Delete P10 and all of its buddies. Save. Wait a few minutes. Okay, file. Refresh. Gotcha. Okay, cool. Ruh-roh. Oh, because that's P9. There we go. Perfect. Now, I think what I should like to do is component. I'll select P9 first. Flip right to left. Do that. There we go. Now we can just wire straight in. Do one of these. Glad those are the same spacing. I kind of don't like getting that close to the pads, but it's allowable. I mean, we got 3 thousandths or 3 thousandths tolerance, I think. So now we can just jump from here over to there. Oh, we only need one. Alright, well, here's what we're going to do. We're going to jump over here. Straight down. Shoot out there. Or better yet, I don't always like doing crazy shots like this, but sometimes it's cool to do it. We'll go down and we'll pull it out of here. Gotcha. Can't really go between there. We'll just raise these up a little bit, that's all. There we go. Whoops. I just accidentally moved the ground plane, I think. Yep. Alright, that's good. Sit her back down there. Alright, this I think needs to move that away and then that way. That's good. There we go, right past it. All sneaky like. I think that goes to number 1. Let's find out. Yep, we're good. Cool. Of course, now I can't run anything else in between there. I'll have to go into subspace and go to either around the back or probably the bottom layer. That's alright. We're allowed. We haven't even made any vias yet, so that's not too bad. Well, let's move these up again. Not so sure that, well, yeah, we got room. If you bump the joints in the traces too close to the pads, it will combine the joint with the pad. You don't want to do that, usually. You know, there's automated tools to do this kind of stuff, but I just don't like doing that. I want to do it manually, because I like manual stuff. Oops. I just bumped the thing again. Where were we? There. I think you can just tell it's got soul when somebody does it manually. It just looks, it's got this look to it. It's not the old manually taped up stuff, but although I would like to tape, I have taped a board before. I've actually taped out a board back in the 90s. Alright, see if we can fit that under there. Yep, we can now. Cool. When I was going to school, we actually taped out a board. We don't have to worry about connecting anything to those from this angle. There we go, cool. A little bit of bumping it around to give her a little more appearance worthiness. Like that. Bump that up a hair. There we go. There she be. Alright, cool. Next. This is going to get a little bit hairy toward the end because it's got a bunch of traces that have got to go around. There's a bunch of stuff in the way, but we'll get it. Alright, so this one, that's got to go there, and that's got to go there. And we can run another one through here. Where do these have to go? Those are going to be on the bottom layer. At least till we get over here. We may put some vias in for those to make it a little bit easier to route. You want to fit as much as you can on each layer. On one layer before you go to the next one, just because that's the way it's done. Alright, do we go through here and follow these ones? I think we're about out of room with that. Yeah, let's leave these alone. We can't make much more room down there. Alright, we'll go underneath it. There's nothing else going over here, so that's good. Let's see. Let's move these a little closer together too. That'll work. There we go. Alright, move this over just a hair. Okay, that'll work. That's good enough. Alright, so we're done with this side of the board, the bottom set of connectors. That's good, that's good, that's good, that's good, that's good. Don't need these. That, and that are all good. The ground continuity is still good. Let's block out the yellow, you know what that stuff is. Okay, so we've got 12 more connections to make. Alright, now we're going to do some trace biasing. We're going to run this on the bottom. Oh, I think we need to shut the top layer off too. Oops. Oh, there we go. Alright. This needs to clear that. There we go. And what we'll do is we'll make a via right here. And we'll bias it vertical on the top layer and horizontal on the bottom layer. There you go. And we do that 3 more times for this. Okay. I want to use as little space as possible with these traces so we can jam them real close together. Oh, I'm kind of backwards, ain't I? We're going to have to move these a little bit. Alright, that's good. Now I can put the red on, and that is about where she needs to be. There we go. Alright, next. Okay. Another green trace. There we are. Cool. Why is this thing all weird? I don't know. Let's make them all weird the same way. And the fourth one's going to be the same thing. Just do that. I think we can bring this one straight across just about. Yeah, we can bring it straight across. Nice. There we go. We'll bring it up just a hair. That'll do. That is close enough. That looks pretty dang good for what we paid. Alright, so we got, let's make sure those are connected. Yep, good. $12 more. We got to do the same thing with that because they're reversed in the order. We probably could have reversed it. I could have laid this out a little better. It'll be alright. Let's do this. We'll just do the same thing again. Actually, even better. I'll do a whole bunch of the same thing. Watch this. There we go. Same deal. Whoops. Except I just accidentally hooked them up to the ground instead of the signal lines. But that's alright, we can change that. There we go. We missed her by far enough. Let's put it a little closer, just to save some space. We'll leave that ground trace in the middle of there, the ground plane. Okay. Then we do the same thing. Whoops. Gotta select the right layer. Fire this out. Go that way. Let's put a couple more kinks in it. We'll go like that. There we go. There she be. Now we wind these down to here. Yep, that's more than 6,000 clearance. That's not. That looks good. Bump this down a hair. Okay, there we go. Whoops, did we already do the routing up? Yep, we did. Cool, okay, so this here goes over there, goes up to that. That's it. Alright, 8 more to go. Or wait. No, 4 more to go. Slick. But these are going to be the hard ones, because we're running out of real estate. Oh, maybe not. Hold on. Watch this. We're going to grab these joints and move only the joints this way. Whoa. Yeah. Okay, post-concussion brain is not liking all these horizontal lines. Ouch. Well, you're going to have to live with it. Because we got work to do, kid. Ouch. Come on, brain. Don't screw me now. There we go. Okay. I think it just rebooted. What do we got to do about this? This is kind of a weird thing. Oh, we can just go straight up through on the top layer. So we'll do this again. Right there. Matter of fact, we'll even line them up with those ones. Oops, I think we're backwards again, aren't we? Yep. Alright, we're going to have to do this inverted. Oh, wait a minute. That's, why can't I delete that? I don't know. We'll delete this one then. Oh. That'll be why. There we go. Now we just bring her up like that. Alright, we're going to drag this down a little bit. There we go. Now, we could actually move these closer together if we wanted to. Would look kind of cool. It would save some more real estate, although we don't really need to. It's always nice to do little tricks. Alrighty. So now, we go from here. That goes to the first one. That way. Second one. Third one. And the fourth one. There we go. I think that's a complete board. Alright. Do that again a couple more times. There we go. That looks about right. I don't know about, but that looks exactly right to me. You want to try to eliminate all the little slivers too as much as you can. Okay. So this goes to that. Yep. Okay, next. This goes to that. Second one from the right. Gotcha. This goes to that. Third one from the right. Yep. Bottom. Bottom. Yep. All right, cool. Okay, next. That's right. That's right. That's right. And that's right. Okay. Right. 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 Now the rest of them are on this side of the board. Top trace to the right. That's good. Second one in. There. Third. Fourth. Okay. First. Second. Third. Fourth. One. Those are done. Yep. What's this? Why does this not light anything up? Oh, yes, it does. I'm just not looking at the right place. There it is. Okay, good. That's it. We got a board. Okay. It's actually a little bit bigger than it needs to be. Let's see if we can get away from these holes a little bit. These ones we're not going to do too much about. Oh, yes, we can. This one doesn't matter because this doesn't have a screw going through it. That's too close. That's good. There we go. Okay, that gives us a little more clearance around that hole. This one's okay. I don't really like the proximity, but it'll be alright. Well, you know what? 10 clicks to the right. There it is. Make sure none of those overlap. Okay, we're good. Let's put some text on it. Alright, let's do this. Watch this. Whoops. Nope, didn't work. It won't let you move text onto different layers. We'll just have to do it the old-fashioned way. Something that Glenn taught me. You always want to have your copyright notice in the copper and in the silk screen. We'll do it backwards on the bottom too. Oh, you know what? I'll bet you if I do that. Heck yeah. Always make sure your text doesn't accidentally cover up any traces either. There we go. Close enough. Alright, got the silk screen on there. P1, P2, P3, P4, 6, 7, 8, 9. Copyright notice on all 3 layers. DB25 male. Alright. That's it. Now we pull the trigger, get the boards made, and wait several days and test them out. I'll see you later. bass on them doohickeys down there.